Good morning, Amherst. Let's do day 2 of Redox. I'm here on Worksheet 3. We're going to step it back, do a couple easier things, and then ramp it back up and get back to Worksheet 5, where most of the work of this unit is. All right, so Worksheet 3 is asking about whether or not these reactions are redox, and then they address this concept of the oxidizing agent and the reducing agent. It's really not that difficult stuff. So first thing you can do is you can look at these types of reactions, and if you want to know if they're redox or not, assign some oxidation numbers. So, okay, here's hydrogen, that's going to be +1. Chlorine likes to be -1. Zinc, that's a free element, it's 0. Here's hydrogen, a free element, it's 0. What about this over here? Well, the nonmetal gets to do its favorite. Chlorine's -1, so that's -2, and zinc can only be +2. There you go. You go, all right, well, hydrogen started as +1. Hydrogen ended as 0. That's definitely a change. Zinc started as 0. Zinc ended as +2. That's definitely a change. Yes, this is a redox reaction. In fact, this one is single replacement. Zinc is replacing hydrogen. So that's always going to be a redox reaction. So yes, it's redox. If it is, identify the oxidation and the reduction. Just remember Leo Ger. I don't care if you draw the cat or not. So hydrogen going from 1 to 0, that's a reduction. So your reduction half reaction. Hydrogen started as +1. It gains an electron. It goes to hydrogen 0. I'm not putting any subscripts on my half reactions. That gets you full credit. Oxidation, zinc starts as 0. Zinc ends as +2. In oxidation, the electrons go on the other side of the equation, so you're going to have 2 electrons over here. Now, in terms of oxidizing agent and reducing agent, kind of a minor concept, but basically it has a lot to do with chemical storage. You keep your oxidizing agents together and you keep them away from your reducing agents. Keep your reducing agents together and keep them away from your oxidizing agents. The oxidizing agent will cause something else to be oxidized. In doing so, the oxidizing agent gets reduced. The reducing agent will cause something else to become reduced. In doing so, it gets oxidized. So basically, I look at my half reactions here, it's kind of backwards. But this went from +1 to 0, that's a reduction. If this is a reduction, this substance is the oxidizing agent. Zinc went from 0 to +2, that's an oxidation. If this is oxidation, this substance is the reducing agent. So over here I'll say the OA is HCl, the RA is ZN. They're always going to be on the left-hand side, reactant side of the equation, and it is actually just backwards. Once you identify your half reactions, just backtrack, and if this is reduction, that's the OA. If this is oxidation, that's the RA. All right, so Worksheet 3, basically, it's got 5 on this page and 5 more on that page. Some of them are double replacement reactions. For example, look at number 4. That's a classic neutralization, acid plus base gives you salt plus water, and neutralization is actually double replacement, and that is never redox. So you could always just say not redox here, but how would you know that? Here's +1 for hydrogen, -1 for chlorine, +1 for sodium, -2 for oxygen, +1 for hydrogen, +1 for sodium, -1 for chlorine, +1 for hydrogen, and -2 for oxygen. Nothing changed. Hydrogen at +1 all the way, chlorine at -1 all the way, sodium at +1 all the way, oxygen -2, hydrogen +1. Nothing changes. It's not redox. So that's part 1 of your lesson. You're going to finish the remaining 8 there. Now let's move over to Worksheet 4. You're going to use Table J. Table J is, well, it's not very elaborate. But basically, more active or more reactive metals will replace less active metals in a single replacement reaction. So the basic idea of here, we list these in order. Okay, let's just go to your table. They ask you, is this reaction going to occur or not? So I look at the left-hand side of the equation, and here's my free element lead. And who is it trying to replace? It's trying to replace copper. So you ask yourself, is lead going to be able to replace copper? Here's lead. There's copper. Lead is more reactive than copper. Yes, this reaction will occur. Yes, you're going to get a reaction. If it doesn't occur, write NR and go to the next. For each one that does occur, write the oxidation, write the reduction, write the net ionic. Okay, here's nitrate. That's a -1 ion for a total of -2, telling me copper was +2. I could break inside, but I see nitrate over here again. They told me lead was 0. Nitrate is indeed a spectator ion. Here it is, -1 for -2. Lead is now at +2, and copper is a free element, that's 0. So, oxidation, well, who moved up? Lead went from 0 to +2, that's oxidation. So, lead went from 0 to +2 by losing 2 electrons. Oxidation electrons go over there. C, write the reduction. All right, copper +2 gained 2 electrons to become copper 0. 2 electrons here, 2 electrons there. If I add those together, indeed, my net ionic is lead 0 and copper +2 go to lead +2 and copper 0. All right, so there are a handful of these to do, 7 more. Will they occur or not? If they don't occur, you just write NR, no reaction, move on to the next one. If the free element is not more reactive, well, let's look at number 3. Here's magnesium, my free element. Is magnesium more reactive than aluminum? I don't know, let's see. Here's magnesium. It is more reactive than aluminum, so yeah, that one would occur. Sorry. Guess we're giving away the farm here. Let's look at number 4. Is copper more reactive than lead? Is the free element more reactive? I don't think so. I think it's the opposite one of what we just did. Here's copper, here's lead. Copper can't replace lead, so number 4 you would just say no reaction. I don't have to worry about that stuff. And then let's continue on with the more difficult, not more difficult, just more intense. Let's do numbers 2 and 3 from Worksheet 5 tonight. All right, so you're going to do the rest of Worksheet 3, the rest of Worksheet 4, and 2 problems from Worksheet 5. I'll make a lesson, post this up. Enjoy, ask me questions along the way. Talk to you soon.